So in the previous video, we had learned rather about the scope and the basic idea as to what chemistry is all about. So chemistry is the study of the composition and what the matter contains basically. So before you delve deep into the subject, the second topic of this chapter is nature of matter. The chapter is some basic concepts of chemistry. So, matter is anything that occupies space and has mass and can be perceived by our senses. So, this is the definition you've been learning from grade 7 or 8, and this has stayed with us till now. So, when we talk about matter, there are two main types of classification that we can provide it with. The first is the physical classification, the second is the chemical classification. In the physical classification, we are not concerned about what the particles contain. We're only concerned about the arrangement. Are they close? Are they far? Is there an attractive force between these particles? And are the physical properties it shows because of that? On the other hand, in chemical classification, we're concerned with what these particles are made of. Okay, so we will first finish the physical classification and then go into the chemical one. The physical classification is something that we've all learned again in our lower sections. So I'm just going to quickly run through it. So you have solids, liquids, and gases. The main way you remember about the properties of solids, liquids, and gases is by understanding rather its arrangement. In solids, the particles are very closely attached. Because of this, see, if you see this, hardly any gap. So which means that these particles have a lot of attractive forces between them. They have a high intermolecular force of attraction. On the other hand, liquids are quite far apart, not as far as gases, but relatively farther compared to solids. So liquids have a slightly less intermolecular forces of attraction, and gases on the other hand have very less intermolecular forces of attraction. So these arrangement of particles is what determines the fact that solids tend to have a definite shape and volume. Liquids have a definite volume, but they do not have a definite shape, whereas gases have no definite shape, they don't have a definite shape or volume. So invariably when it comes to gases, solids you can observe, right? You can say, okay, this particular pen, it's a solid because it does not move, it has a fixed shape and it has a fixed volume. Liquids on the other hand, if you see your water bottles, and if water gets tipped over, obviously the water will spread in all directions or in the direction of flow, so it has a tendency to flow, but the volume of the water stays the same. But gases on the other hand, they neither have a definite shape or a definite volume. The volume part is a little confusing, so I'd rather teach that with an example. So assume you have a box, a small tiny box, and you have like few molecules of gases within it. Okay, now again assume that you are transferring all of these contents to a bigger box. So the definition of volume is the amount of space which is getting occupied by matter. So amount of space which is getting occupied by matter, and since gases don't have a definite shape, they will spread inside the box, which means the volume changed from here, which is lesser, to a higher one, which this is why we say that gases do not have a definite volume. Okay, so this is about the physical classification. Next is the chemical classification. Here's where things are a little bit, I wouldn't say complicated, a little bit technical, right? So as I told you before, in chemical classification, we are concerned with what these particles have. Right? In physical, we just said, okay, these are particles, and they're so far apart. But when we talk about chemical classification, we are concerned about what these contain. With respect to that, we have two main classification types, or two main types, yeah, pure substances and mixtures. So pure substances, they contain only one type of atom or molecule, whatever it is, but it has only one type. Whereas mixtures will have two or more types of atoms and molecules. Okay, so in pure substances, again, it's further classified to give us elements and compounds. Elements, you've learned these in the periodic table chapter in class 10, which was all about, you would have learned about the basic idea behind the periodic table. You have you have the metals on the side and the center, the non-metals which are on the right side of the periodic table, metalloids are in between, and inert gases are on the right extreme corner. So these elements can exist either as atoms or molecules. Okay, so let's go to examples of these and maybe you can understand it better. Okay, so when I talk about examples of metals, we could take the example of sodium, iron, gold. Non-metals on the other hand, examples could be oxygen, nitrogen. Okay, metalloids examples could include silicon, arsenic, and inert gases. I'll take two examples, helium and neon. Okay, so when I wrote these, I just wrote them as their symbols, but when I wrote non-metals, I wrote O2 and N2. Okay, this is a molecule of nitrogen, this is a molecule of oxygen. So these elements cannot exist alone, whereas these elements are capable of existing alone. So we call them, these are atoms, whereas these are molecules. So atoms are the smallest indivisible particle is what Dalton said, but of course he was proven wrong. But it's the smallest particle was what it was thought to be rather. So the properties of metals would be shining. They are shiny. They have good conductivity. They're good conductors of heat and electricity. They are malleable and ductile. Now, this is another tip that I have. Okay, when you talk about malleability and ductility, MALLEABLE and DUCTILE. So when invariably you get confused between these two words, so you can remember malleable has two E's in it and ductile has one I, which means malleable means it can be converted to sheets and ductile means it can be drawn into wires. So metals are malleable as well as ductile. Non-metals on the other and metals are also very hard. Non-metals on the other hand are not malleable, they're not ductile, and they're not good conductors of heat and electricity. So basically the properties which are shown by metals, the opposite of them would be non-metals. Metalloids have the properties of both metals as well as non-metals, whereas inert gases do not have any capability of capability of undergoing a chemical reaction. So they are pretty stable. Okay, so elements, the basic definition of element is that it's the smallest, purest, or rather, it's the simplest form of a pure substance, and it cannot be decomposed or formed by normal physical or chemical reactions or means. The next is compounds. Before, again, here we are going to look at two examples of compounds, and then I'm going to talk about its definition. Okay, so let's take the most commonly known one of them all, water. Okay, so right, H2O. Nobody on this planet is going to write the formula of water as H3O or H4O. So a compound consists of two or more elements in a definite ratio. Okay, so no matter where you go, the formula of water will remain H2O, which means it has two hydrogen atoms and one oxygen atom. And this formula will not change irrespective of where you go and what the source is. We'll be learning in detail about about this in one of the theories of chemical combination. The second property of compounds is that now you have hydrogen and oxygen. Okay, hydrogen is supposed to be a gas in room temperature. Okay, and oxygen is also supposed to be a gas, whereas water is a liquid. Okay, this is with respect to its physical property. when hydrogen is supposed to be quite volatile, okay, so even if there's a little sparkle, there'll be a huge boom. Because of that, it can cause a lot of flame, I mean, it can cause explosions. um, so this, on the other hand, water is liquid and it is quite stable, and we basically drink it, right? So the properties of these elements are lost when they form a compound. Okay, similarly, let's take another example if you've not understood this. um, Again, we'll take another gas. Okay, we'll take a gas rather, carbon dioxide. First of all, you will not write CO4, okay, as carbon dioxide. We don't call CO4 carbon dioxide. We will not call CO5 carbon dioxide, right? So carbon dioxide will have one atom of carbon and two atoms of oxygen. Now, carbon is a black, generally considered black, and it's a solid, whereas oxygen is a gas. But carbon dioxide is also a gas. So the property of carbon has changed to give us carbon dioxide, and which is a gas. So this shows that there is a change in property. Not only that, again, its color, it's supposed to be a black color. You don't see, carbon dioxide is colorless. You can't differentiate the presence of carbon dioxide in one particular place and not the other, right? So this is the basic definition of compound. It consists of two or more elements in a fixed proportion. And one important thing about compounds is that these elements lose their properties to form compounds. Okay, so compounds are classified into two. One is organic, the second is inorganic. So inorganic compounds are present in, which are available from non-living things. So they could be sodium chloride, okay, from seawater, all sodium chloride, baking soda, washing soda. All of these are inorganic compounds, whereas organic compounds are the ones which are obtained from living organisms. So examples could be carbohydrates, fat, wax, etc. So inorganic compounds are not obtained from living organisms, and organic compounds are obtained from living organisms. The next and the last topic in this um, heading are mixtures. So mixtures consist of two or more substances. That's what I said in the beginning. So let's take the example. Okay, so we are taking water and salt, a table salt, or common salt. So that's sodium chloride. Okay, now so if I want a mixture between these two, I can say that a 5 gram of sodium chloride containing with 10 ml, okay, that's a little too high, so I'm going to go with 100 ml of water is also a mixture. And if I have 2 grams of sodium chloride and again 100 ml of water, that is also considered a mixture. So unlike pure substances, mixtures can have two or more substances in any ratio. It does not matter as to what the ratio is. It's just that they both are mixed together. And now, if assume you've dissolved a little salt in water, I mean, you could do this at home. You put it outside, leave it outside, and due to evaporation, you will get back the salt, which means the property of that substance is not changing. This substance is not losing its property because it is dissolved in water. So mixtures, there are no chemical reactions taking place, it's just together. Okay, so it is basically classified into two, homogeneous and heterogeneous mixtures. So homogeneous mixtures, you cannot see the point of difference. Okay, whereas heterogeneous, you can see the point of difference. First, we will go to heterogeneous because they are more familiar to us, I guess. So in our kitchens, when the food after the food gets prepared, water is gently added to the vessels so that they get soaked and they get cleaned later. If you notice, on the top you have teeny tiny droplets of oil floating. This means that water and oil do not mix. And you can see that point of difference. Okay, so when I mix water and oil together, we'll be able to see the point of difference very clearly, and we can make out the fact that water is separate from oil. Same goes for, let's take the example of perhaps sand and water. So if you have sand, it will settle at the bottom, and you will have water which should be at the top. So these mixtures have the point of difference they have the point of difference visible, whereas in case of homogeneous, they are not. If you mix salt and water, taking the same example, you will only see one clear solution. You will not see, okay, there is a particle of sodium chloride. No, because homogeneous mixtures, they are uniformly mixed. Okay, commonly known examples of homogeneous mixtures could include air. You cannot see the particles of air separately. And also, one more important thing about homogeneous mixture, the composition is uniform throughout. Okay, so another example is sodium chloride and water. Heterogeneous is sand and water and oil and water. Okay, so what I usually tell anybody who asks me about the question about how to remember the difference, always remember the example for each of these. So when you talk about heterogeneous, think about oil and water. What does oil and water mixture tell you? It shows the fact that they both can't be mixed. So here you can see the point of difference clearly. In homogeneous water and sodium chloride, you cannot see the point of difference clearly. So you need to remember, it's easier to remember an example for each of these and then come to the definition instead of trying to, memorizing it and then doing it. So just remember the example and you're good to go. Okay, so matter is anything that occupies space and has mass. It has two primary classifications. One is the physical classification, one is the other is the chemical classification. In physical, we have solids, liquids, and gases. So solids, particles are closely packed. Liquids, they're further apart, and gases, they're very far apart. Chemical classification, and we learned about the properties of solids, liquids, and gases. Chemical classification, it has pure substances and mixtures. Pure substances contain only one type of atom or molecule. These have two or more. Elements can exist as atoms or molecules, and they are the simplest form of pure substances and cannot be formed or removed cannot be formed or broken down by normal physical and chemical means. They're further classified to give us metals, non-metals, metalloids, and inert gases. Don't forget my tip, malleability and ductility. So malleable, it has two E's, you can remember it as sheets, and ductile has an I, so you'll remember it as wires. And compounds are substances which have two or more elements which are in definite proportion by mass. So these elements tend to lose their properties when they lead to the formation of compounds. The compounds are classified into two, inorganic compounds and organic compounds. Inorganic compounds are obtained from non-living sources, whereas organic compounds are obtained from living sources. Examples of inorganic: sodium chloride, baking soda. Organic is carbohydrates, fats. The next one is the mixtures. Mixtures consist of two or more substances in any ratio. Okay, and mixtures are further classified to give us homogeneous and heterogeneous. Quick tip, do not remember the definition but learn and remember rather the example for each of these. So homogeneous has sodium chloride and water, which means that you can't see the point of difference clearly, whereas heterogeneous, oil and water, you can see the point of difference clearly. That's all for this topic. Do check out the next video, which is going to be about the properties of matter and their measurement. I hope you understood this. Thank you.